All right, class. So I've shown you the activity series and I've shown you how to use it, but let's do some more practice problem to make sure that you are getting this down. So again, these are my two options for my redox reaction. And just because I give you a redox reaction doesn't mean it's going to happen. And the question is, which of these is going to actually happen? So the way to do this, first of all, we need to figure out if which one is going to be the one who's going to be oxidized, which one is going to be the one who's going to be reduced. So over here, I have nickel. What's the charge on nickel? Charge on nickel right now is 0, right? Okay, so I have nickel that is 0. Now, nickel 0 goes to nickel plus 2. So nickel 0 goes to nickel plus 2. That means nickel is going to be oxidized. It's 0 right now. Nickel 0 goes to nickel plus 2. It gets oxidized. Okay, so this is going to be my oxidation. Now, what's going to happen to silver plus 1? So silver is silver plus 1, right? It's silver plus 1. So now the only option it has is to go to silver 0, which means it's going to get reduced because it's going to go from silver plus 1 to silver 0. Plus to 0, you're going to get more negative, so it's going to get reduced. Okay, now when I come over here, it's going to be the opposite. So now silver has a 0 charge. So if silver has a 0 charge, if a metal has a 0 charge, the only option it has is to go to plus, right? It become oxidized because metals, they love to lose electron and become more positive. So oxidation. Now over here, nickel is nickel plus 2. So if I'm nickel plus 2, the only option is becoming nickel 0. So it's going to become reduced. Plus 2 to 0, you become more negative. So far, so good. Okay. All right. Now the question is, which of these two is going to happen? So in one of them, the nickel is being oxidized. The other one, silver, is going to be oxidized. What you're going to do, you're going to look at this activity series and let's figure out where they are. So nickel is right here and silver is right here. So what I mentioned before is that the one that gets oxidized has to be higher on the activity series than the one that it gets reduced. So the one that gets oxidized, the one that is going to do oxidation, is going to be higher up on the activity series than the other one. And the reason for that is these are the ones that are really want to be oxidized. As you come down, they don't really want to be oxidized. This is why gold is down here. Gold does not want to be oxidized. That's why gold is great for jewelry. You can wear your gold jewelry, take a shower with it, do whatever you want. It's not going to get oxidized, right? Because it's down here, and down here they don't want to be oxidized. Up here, they really want to be oxidized. Okay, so which one is going to happen? Set A or set B? What do you think? So the one that gets oxidized has to be higher on this activity series. The higher one is nickel. So this is the one that is going to happen. This is the one that's going to happen because nickel is going to be my oxidation and silver is going to be my reduction. So far, so good? Okay, beautiful. Let's go to the next practice problem. Here is our next one. Again, I'm going to give you two sets and I'm going to ask you which one is actually going to happen, which redox reaction will actually going to happen. The same as before, let's figure out what's been oxidized, what's been reduced. Over here, Sn has a charge of 0. Do you agree? Is 10 a metal by itself has a charge of 0. Now, if you have a 10 that is charge of 0, the option that it has, it can go to 10 plus 2. So it's going to get oxidized because the only option it has, you go from 0 to plus 2, you become more positive, you become oxidized. Now, let's go over here. Now, Mg is plus 2. So if Mg is plus 2, now the only option it has is to become Mg0, right? So it's going to become reduced. So far, so good? Okay. Now, let's come over here. Again, Mg, a metal by itself, has the oxidation number of 0. Now, the only option you have, it become to lose electron and become Mg plus 2. So the only option it has is to become oxidized. Now, the 10 is plus 2. Now, if the 10 is plus 2, so right here, 10 is plus 2. Let's see. The only option it has is to go to 0, right? Okay, so then it's going to be reduced. So far, so good. Now what I'm going to do, I'm going again to find mg's right here, and 10 is here. What did we say? Repeat after me. The one that gets oxidized has to be higher up on this activity series than the one that gets reduced. Because again, the one on top, they really, really want to get oxidized. The one on the bottom, not so much. So here, in order for this to happen, the mg has to be the oxidation one, and then the 10 has to be the reduced one. Okay, this is the one is going to happen. So far, so good. Okay, let's do harder practice problem. Let's keep going. Here is the next one. This one is hard. Again, do this first and then watch this video. So Cl2 has an oxidation number of 0. Okay, Cl2 has an oxidation number of 0. Diatomic molecule have an oxidation number of 0. Now let's come over here. So Cl2 has an oxidation number of 0, and then the option it has is to go to Cl minus, right? Remember, non-metals, they don't want to lose electrons, so they don't become positive, they become negative. So Cl2 0 goes to Cl minus, okay? So if you have 0 going to -1, you become reduced. So far, so good? Okay. Now, over here, copper has a oxidation number of 0. Metals on the opposite part. Metals, they want to lose electron. So if I have a copper 0, it's going to become copper plus 2. So that is my oxidation. Let's come over here. So here, Cl has a minus charge. Again, if Cl has a minus charge, then it can go to 0. It can become Cl2. It can become an oxidation number of 0. So if you go from -1 to 0, you become more positive. You are oxidation. Again, look over here. 0 to -1 or -1 to 0. Now copper is plus 2. Again, it could go back and become copper 0. Plus 2 to 0, that become more negative. You're going to be reduction. So far, so good. Okay, and the question is, which set is going to happen? What I'm going to do, I'm going to find them on here. Here's was my Cl, and my copper is right here. Okay, in order for this to happen, the one that copper gets oxidized will happen, because that's going to be the one that gets oxidized is going to be higher up on the activity series. So which one that is? That would be B, because here's the one that copper. Oh, no. Just kidding. I was testing you guys. That would be A. You passed the test. Because copper has to get oxidized. Copper gets oxidized. So this is the one that is going to happen. So far, so good. Okay. Beautiful. Last one. Let's do one last practice problem. All right. So if you look at this one, I have H2, okay? Diatomic molecule. The oxidation number is 0. And then what could H2 happen? H2 could go to H plus, right? H2 could go to H plus, 0 to plus, you become oxidized because you got more positive. Now zinc is plus 2. If zinc is plus 2, what's going to happen? Zinc is going to go from plus 2 to 0, so it's going to become more negative, so it's going to be reduced. Let me come over here. Again, this is H plus. H plus is going to go to what? H plus is going to go to 0, because it's going to be H2. The atomic molecule is 0. To go from plus to 0, you got reduced because you got more negative. Now, again, zinc over here has an oxidation number of 0. Now, what's the option it has? Zinc can go to zinc plus 2, because it's a metal, it's going to get oxidized because they want to lose electron and then become more positive. So this is my oxidation. Okay, the same question as before. Which set is going to happen? All right, let's do this. Here's my H2, and then zinc. Where is zinc? Here's my zinc. Remember, the one that gets oxidized has to be higher up than the one that gets reduced. So without even looking at my set, I'm going to say, in order for this to happen, zinc has to be oxidized and then H2 has to be reduced. Which one would that be? Zinc oxidized and then H has to be reduced. Okay, So this is going to be my the reaction that will happen. That's going to be my choice. Sounds good? Okay, so hopefully this will give you enough practice problem to be able to do this on a lab exam or quiz. I will talk to you guys next time.